Friends, I hope you are doing well. So I am here to start a new question, find a peak element second. In this question, what we have to find and what the question says. First of all, it says find a peak element. It has a second part. First part also has something which is in the 1D format. But in this question, we have a 2D grid given. So the question says a peak element in a 2D grid is an element that is strictly greater than all of its adjacent neighbors to the left, right, and top and bottom. Given a zero-indexed M-cross-N matrix MAT where no two adjacent cells are equal, find any peak element MAT I, j and return the length to array I, j. You may assume that the entire matrix is surrounded by an outer parameter with the value -1 in each cell. You must write an algorithm that runs in deco of m log n or n log m time. Okay, so what we have to find now? Uh, Suppose we have a small grid like 1, 4, 3, 2. It is a 2 by 2 grid. So, okay, so we have to suppose like in the outer parameter of the grid, we have -1 all, -1, so that any corner element or any side element which has only two adjacent elements in the grid or three adjacent elements in the grid have if greater value than all its neighbor, then it is also considered as the peak element. So that's why we have to consider -1 in its outer parameter. Now we have to find any peak element in this grid. Suppose in this grid we have 4 and 3 in the outer skirt of as a peak element. Okay. Now in this grid also we have 30 and 32 as the peak element. We have seen that in the previous question also. So let's start the question. What the constraint says. There is also M and 500, which is something upon like 225,000 approx. Okay, 2,50,000. Sorry. Okay, so now we should solve this question. And how we can solve this question? Suppose we have a mat. So first of all, find the size of the matrix, and this is the length, the height of the matrix, which should be like this. Now what we have to find? First we considered suppose a low element and a high element. We should suppose a whole column exactly. So in low is equal to 0, high is equal to m minus 1. Now it is looking like good. So apply a binary search on it, because as a constraint said, we can apply a binary search in this, because we should do it. Okay, so now low, high, calculate the mid, the binary search pattern. What we have to find now? We have to find a mid element, which should be a column. It should be a column we have. So we have the column, mid column. In this column, we have to find an element which is the maximum element in the column. Which row has the maximum element in this column? Okay, so now we have to consider only in this column that which row or which element has the row which has the greatest element in this column. So for the row in this column, we have find a function or write a function find max element, which we have to pass matrix and the column number and size of the matrix. So it will give me a row number. This function returns me the row number which has the greatest element in this particular column. So apply this thing on the row we have. Now we have this. Suppose we have a maximum element as 0. Can we take it? Yes, we can take it because every element in this matrix is greater than -1. It means it is greater than or equal to 0. So we can take this. Index, what we have to take, suppose initially. So we can take -1 as the initial index because and no row has -1 index. So we can take it. Now we can apply a loop on this. Okay, so if my max C element is less than, or we can say in another words that if any element is greater than max C in this particular column, then we can replace it by this element, and my index should be that row, and in the answer we return that row. Now we have int row find max. Okay, so we have find now column and the row. Now what we have to do? We have find a column. Now what we do? We have find an element which is the greatest element in this column. So we have cleared the conditions from top and bottom. Now we have to find the conditions from left and right, which we can check by an element just in this particular row, in the previous and the next element from this element. Okay, so now we check as the left. Initially we find it as the -1, and also we have a right which is also initially -1, and we check if we have column col -1 greater than equal to 0, then we assign it as left, that is as my I, no, not I, but row col -1. And if my col +1 is less than m, then we assign it as mat row col +1. It is fine, I think. Okay, so according to me it is fine. Now what we have to do? So we have clear left and right. We have find it. Now check if it is greater than left and right, then we can all set. So if my mat row col is greater than left and my mat row col is greater than right, then we should return a 1, or not 1 exactly, but the row and the col. Else if my mat row col is greater than left only, then we should take a consider a thing that my left is less than that element. So my peak element should be in the right, because in right we have a bigger element. Yes, we can take this. So my low should be equal to col +1, as we have take a condition as this. Now for the sake of simplicity we return it as -1, -1. So what we should consider? We should apply a thing that it should work. Did it work? Yes, it is accepted. Take the submit button also. Can we submit it? Yes, it works. Fine. Okay, so this is a problem statement and this is a solution for it. Okay, and now we go of O n log m solution, as the time complexity is the big O of n log m complexity is big O of n log n, and the space complexity is big O of 1. So it is a proper solution for it. You can explore it and take a dry run for it. So this is the video. Hope and do great things.